moving on. We have 4 more examples. We can do this. We got to talk about a reciprocal. So this is when you're going to divide by a polynomial, which just means that you're going to put it over 1 and flip it. Over 1 and flip it, okay? You see it? They're just saying that's what the reciprocal is. Okay, you flip it upside down. So when we have a dividing, here it is, you see your dividing symbol? We need to remember that this is over a 1. So when we rewrite it, you still flip the second item. You just make it 1 over x squared minus 3x minus 4. That's it. That's the only things I have to remember. It's 1 over. Now I need to factor. Factor the top left. If you want to pause the video and try factoring it, it's probably a really good idea. You should get 3x times x minus 4, GCF, over 5x times 1 over, factor this. Pause the video if you need to. X minus 4, x plus 1. Cancel what you can. Binomials with binomials. Now look at the monomial. This x and that x. The top you're left with 3 times 1, which is 3. The denominator you're left with 5 times x plus 1. That's it. The got it problem, do the same thing. Remember that a polynomial is always over 1 if it's not a fraction. So you get z squared minus 2z plus 1 over z squared plus 2 times 1 over z minus 1. So I flipped it and I changed it to multiplication. The numerator, we need a factor now. You get z and z minus 1 minus 1. You guys have to be good at factoring. Pause the video. Now, this is hard. The bottom one doesn't actually factor because there are no perfect squares, and it's an imaginary factor, but we're just going to copy it down. Trust me that it does not factor. If you want to know why, just come in and ask, okay? I can answer it better kind of one-on-one here. Now, you see the z minus 1s? You only get to cancel one of those with the binomial on the bottom. Nothing else cancels because they're all part of binomials. You can only if you're going to cancel a binomial, you need to cancel the whole thing or nothing at all. You get z minus 1 over z squared plus 2. And that's it. Now, the next little part down here talks about this thing called a complex fraction. A complex fraction is this. It's a fraction within a fraction. You can write that down if you want. A complex fraction is just a fraction inside of a fraction. You're going to learn how to rewrite it. So don't let all that kind of scare you. You're just going to learn how to rewrite it. Let's take a look at problem 6. Do you see that complex fraction? It's a fraction within a fraction. Well, that's alright, guys. It's really just this. Divide by that. So let's write it in something that makes sense to us. It's 1 over x minus 2 divided by x plus 3 over x squared minus 4. All I did is I rewrote it into something you understood better, right? It's the same thing. Now we need to flip. So 1 over x minus 2 times x squared minus 4 over x plus 3. Now we need to factor. Well, the left doesn't factor. Pause the video if you need to. The top right factors to x plus 2 and x minus 2. This is something I'm assuming you know how to do. If you don't, you really need to go back and watch chapter 8 videos. Cancel the x minus 2's. You're all done. You just have to rewrite. Your final answer is x plus 2 over x plus 3. Don't cancel the x's. They're part of binomials. Examples, got it 6. Okay, there's your top, there's your bottom. Let's rewrite it so it makes more sense to you. It's not quite as scary. 1 over q plus 4 divided by 2q squared over 2q plus 8. By the way, you can skip that step and go straight to this step right here, the flip step. 1 over q plus 4 times 2q plus 8 over 2q squared. We do that anytime you have division. Now you need to factor, and again, you might want to pause the video and test your factoring skills. The left doesn't factor, 1 over q plus 4 times. The bottom right doesn't factor, but the top right, you can pull out a GCF and get 2 times q plus 4. The reason that helps so much is because now q plus 4s can cancel, and the monomial 2 and 2 cancels. On the top, that leaves you with 1, and on the bottom, that leaves you with just q squared. Notice that we've stopped stating our excluded values. Your excluded values you would always state after you factor. In this case, you would tell me q couldn't be -4 and q couldn't be 0. We're saving ourselves a lot of time, and I'm going to assume that you remember how to state excluded values. If you don't, you need to go back, watch the beginning of this lesson or the lesson on 11-1.